مرحبا جميعا, this is a tutorial to help you connect your modules to form your CPU. For the sake of this tutorial, I created a trivial hardware design that uses the modules we created with the last tutorial, which are the ALU والmemory. So let's look at what this hardware design does. في عندي ال ALU, it performs an operation on two inputs, input 1 و input 2. That operation can be addition or subtraction. بعدين رح يطلع معي a result. هلا هذا الريزلت أنا هون ما عم بستعمله. بس I've added another signal, it's called the 5 flag. هلا what this 5 flag is basically it has a value of 1 when the result is 5, and it has a value of 0 when the result is not 5. And I use that as an input للmemory, and it acts as the write enable. فمثلا let's take an example. إذا I'm adding two numbers, 2 and 3, the result is going to be 5. For the 5 flag will have a value of 1, because the 5 flag has a value of 1 when the result is 5, and 0 when the result is not 5. So the result is 5, the 5 flag has a value of 1. So now the write enable signal will be asserted. So I can write to the memory. What's going to be written to the memory? What's going to be written to the memory is the value of the first input to the ALU. So in this case, 2 is going to be written to the memory. To which location in the memory is it going to be written? It's going to be written the address that I provide. So this is essentially what the hardware does, but let's see how we can implement it in Verilog. Before we do, I just want to go over the memory and ALU modules because I've made some slight modifications. أول إشي بالmemory module, I've initialized the first 5 addresses من 0 ل 4 ل all ones in binary, which is equivalent to F's in hex. And I've synchronized writing with the clock. So لما يكون عندي لما clock signal يتغير, إذا عندي write enable, then I'm going to write to the address provided. Otherwise, I'm just going to read the output data at the given address. بال ALU module, it's the exact same thing. I've just added one more signal اللي هو ال 5 flag. وخلينا نشوف how this 5 flag is assigned. فأول إشي, I want the result to be equal to a value of 5 بالدecimal, and I want the clock to be equal to 1. يعني the 5 flag is only equal to 1 in the first half of the cycle. لأنه be the first half of the cycle, the clock is equal to 1. This condition, you might need it in some cases. Keep it يعني in the back of your mind, because you might need to use it in some situations in your CPU. This is essentially how the 5 flag works. فهلا let's get to writing the CPU. بالCPU, I need an instance of my ALU and an instance of my memory. بس أول إشي I need to include those files. I'm going to include alu.v, that's the ALU file. I'm going to include memory.v. هلا I need the actual module. It's going to take inputs and outputs, and I'm going to end it. هلا as inputs, I need the clock signal, the reset signal, the operation for the ALU. I also need 2 4-bit inputs, which are input 1 and input 2 لل ALU. I also need a 10-bit address للmemory. هلا للoutputs, I need the 4-bit result, or I need the 32-bit data memory output. Okay, so now I need an instance of my ALU. رح أسميها ALU1. وبعدين I need an instance of my memory. رح أسميها memory1. هلا لل ALU I need certain inputs. Let me just add my ALU هون on the side. في عندي input 1, which takes input 1, input 2, which also takes input 2. بعدين عندي الclock, reset signal, operation. I also have my result, and I have my 5 flag. هلا هون بالinputs والoutputs ما عندي 5 flag because the 5 flag isn't an input nor an output. It's a wire that connects an output from the ALU to an input بالmemory. فهون I need to define a wire. I'll call it 5 flag. طبعا let's say I was connecting the output الresult من ال ALU ل input للmemory. For the result من ال ALU is 4 bits. So I would define the wire in this case as a 4-bit bus. وهون بسميه مثلا ALU result. But in this case I'm just using the 5 flag, which is just a 1-bit signal. I'll just leave it as a wire. فهون محل ال 5 flag بدي أحط the signal that I've added. Maybe to differentiate we can call it 5 flag underscore T. Okay, بعدين للmemory نفس الاشي. Let's open it here. بعدين we need the address. We need the clock. We need the right enable, which is the 5 flag. We need the right data. هلا we'll get to the right data, and we need the output data اللي هو data memory out. فللرايت data في عنا مشكلة اللي هي الميموري بتاخد 32 bit data, بس input 1, which is the data that's going into the memory, is only 4 bits. So what we can do is we can add the input 1, but we need to concatenate it with something عشان we need the input to be 32 bits. So what I'm going to concatenate it with is 28 bits of input 1 of 3 اللي هي the most significant bit من input 1. So what this does is it sign extends input 1, it makes it 32 bits لأنه هون عندي 28 bits و input 1 is 4 bits. So when you add those, that's 32 bits, and then I can store it in the memory. So I just need to make sure that this is correct syntax. We might need to add some brackets here. Okay, so that should be it. هلا بروح على test bench. The test bench is the exact same test bench, بس بدال ALU or whatever I was testing, I added the CPU because this is what I'm testing now. I added the test cases that I wanted with input 1, input 2, the operation لل ALU طبعا والaddress للmemory module. فهلا I'm just going to run the commands اللي أخدناهم وبدي أشوف output. So when I'm adding 7 and 1, the result is 8. So the 5 flag isn't activated, so I can't write to the data memory. فعندي at address 0, the data is this big number, which is the number I've initialized. If I open the memory here, this is the number I've initialized, with equivalent in decimal is that. بعدين هون I'm adding 3 and 2, and the result is 5. So I can write to the memory. So بروح address 0, with the output is 3, which is the first input. That makes sense لأنه the output was 5. I was able to write to the memory. What did I write to the memory? My first input. بعدين لساتني على address 0, but now I've changed the inputs لل ALU. I'm adding 1 و 6. The output is 7. بس لما أشوف إيش في address 0, it's still 3. I couldn't change that value لأنه the result wasn't 5 and I couldn't write to the memory. So hopefully this tutorial is gonna help you in connecting the modules, so you know exactly how to connect outputs of certain modules as inputs to other modules and hopefully form your complete CPU.